my friends from all over the world. In this video, we're going to solve a problem about the maximum efficiency of power transformers. I took this problem from the 2014 Petrobras entrance exam. Petrobras is the largest oil company in Latin America, and many engineers worldwide desire to work there. The exam was originally written in Portuguese, the official language of Brazil, but I decided to translate it to English to show to the world how electrical engineering exams are like in Brazil. To follow, go to the description of the video. Let me read the problem. The maximum efficiency of transformers, Petrobras 2014, question 23. In a petrochemical plant, a transformer with the following characteristics was installed: apparent power of 1250 kVA, 13.8, 0.48 kV, the primary winding connected in delta, and the secondary winding in grounded Y, presenting no load losses equal to 1.8 kilowatts, copper losses equal to 5 kilowatts at full load, and the power factor of 0.9. What's the load value in kVA for the maximum efficiency of this transformer? So this is the question. But before we go to calculate the maximum apparent power of the load for the maximum efficiency of this transformer, we need to understand the concept of efficiency. What is efficiency? Efficiency is the ratio between the output power and the input power. Okay? The output power in terms of the output current is V2 I2 times the cosine of the angle. And the input power is V2 I2 times the cosine of the angle plus the core losses plus the copper losses. But the copper losses depend on the output current. So it's going to be I2 squared times the resistance of the copper wires. Okay, the maximum efficiency, we want to maximize this. How do we do that? How do we maximize the efficiency? We take the derivative with respect to the output current of the efficiency has to be equal to 0. When we make the derivative of the efficiency with respect to output current equal to 0, we maximize the efficiency. Do you guys get it? Okay. And if we take the derivative of this expression here, I'm going to let you try it, but I'm going to tell you in advance that it means that the core losses have to be equal to the copper losses. Okay? You are going to develop this derivative and you are going to reach this conclusion here, that when the core losses are equal to the copper losses, we have maximized the efficiency of the transformer. Okay? Now that we know this, we have to understand how we are going to use this concept here. Okay, this is kind of theoretical, but we have to understand this to calculate what the problem is requesting us to calculate. Next, after discovering this, we need to additionally differentiate some things related to the output current and the copper losses. For example, if I call PCUFL the copper losses at full load, okay? If I call this the copper losses at full load, and if I call this X squared PCU, this is going to be the fraction of the copper losses at full load of our interest, because we are not interested in the copper losses at full load. We are interested in the fragment, in the portion of the copper losses at full load. And why x squared? X squared because this power, as we saw, PCU, is proportional to the square of the output current and the resistance of the copper wires. So this x squared is going to represent the fact that this power is dependent on the square of the output current. Knowing this, we can go ahead and we are going to see that we want this. We have already concluded that the maximum efficiency is reached when the copper losses are equal to the core losses. Okay? So this is what we are going to use. So we want this portion here, not the copper losses at full load. We want this portion here to be equal to the core losses. So x squared times P CUFL equal to P core. Okay? So ultimately we're going to reach that x is going to be equal to P core over P CUFL, the square root of it. So this factor here, the x factor, is equal to the square root of the ratio between the losses in the core and the losses in the copper wires at full load. Okay, so how do we use it? I'm going to write an expression and you are going to see what I mean by this. Okay, so the apparent power of the load that's going to make this transformer work in its maximum efficiency is going to be equal to the apparent power of the load that's going to cause the maximum efficiency is going to be equal to that the apparent power of the transformer at full load times that ratio that we discover, P core over P CU full load. Okay? Are you guys understanding everything? So, to finish this simple problem that is not so simple if you can't come up with this, once you've come up with this, you can see that this problem is very simple, but the catch is to come up with this ratio here, and we simply plug the values and we discover that the maximum efficiency is going to be reached when 1250 kVA times the ratio between the core losses, which will be 1.8 kilowatts, and the copper losses 5 kilowatts. And when we do this calculation here, we arrive at the final value 750 kVA. So this is the solution of the problem, my friends. Okay, this is the solution. I am going to leave the exercise in the description of the video for you guys to follow. Try yourself, okay? Try using your method. If you can find 750, okay. If you cannot, use my method, the method that I described in this video. Alright, my friends, this was the video that I wanted to make. I hope you guys enjoyed it. If you want to talk to me, simply leave a message in the channel. And if you want to book a lesson with me or any kind of other thing, just contact me using my WhatsApp number. My friends, this was the video. Goodbye!